Alright, so I have 4 x's and I have 3, 4, 5, 6. Combined all my like terms, that equals 238. I don't need to get all my variables on one side, they're all here. So I'm going to isolate my variable. Well, here's my variable. What do I need to get rid of? If I want 4x alone, I need to get rid of these 6 positives. The inverse is 6 negatives. Keep my balance. Cancel these out, and I get 4x equals 232. If I want to get x alone, I'm going to divide both sides by 4. And I get x equals, let's see, 4 times 5 is 20. 4 times 8 is 32. Now I didn't do this last time and I should have. X is 58. So what are my 4 consecutive integers? Well, if x is 58, the next one is that plus 1, which is 59. The next one is x plus 2, which would be 60, and 61. If you add all those up, you get, let's see, 120, 220, 237, 238. Ta-da! The one before that, we determined that x was 38. So if I go back here, that means my first integer was 38. My second integer would be 38 plus 1 more, which is 39. And my third integer would be 40. And if you add those up, you get 117. Da, 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 da. Okay, let's keep moving. Find 3 consecutive integers such that 3 times the least is 23 more than twice the greatest. Okay, once again, we're going to find 3 consecutive integers. There's the first one, the second one, the third one, such that 3 times the least. Well, which one of these is the least? I'm pretty sure it's x. 3 times the least would be 3 times x is equals 23 more than. 23 more than means I'm going to add 23 to something. 23 more than what? 23 more than twice, that's 2 times, the greatest. Which one of these is the greatest? Wouldn't this be the greatest? Twice the greatest, all of that. Hey, I have an equation that I can solve. So I'm going to distribute. So 3x equals 2x plus 4 plus 23. Bring this term down. I'm going to combine like terms. 4 and 23, all positives, is 27 positives. Bring down my 2x, and all that equals 3x. Oh, I have variables on both sides of my equation, so I need to either get rid of my 3x's or get rid of my 2x's. I choose to get rid of these by subtracting 2x on both sides to maintain my balance. These cancel out. I get 27 on the right side. Oh, how nice, and I get x on the left side. So my smallest consecutive integer is 27, so that means this one is 27, the next one is 28, and the next one is 29. And this says 3 times the least, so 3 times 27 would be 81, is twice the greatest. The greatest is 29, twice the greatest would be 58. Whoops. Oh yeah, twice the greatest. So twice the greatest is 29. I'm sorry, 58. Twice the greatest plus 23. If you add those two numbers together, you are going to get 81. Okay? Next one. Find 3 consecutive integers such that 50 more than the least is 40 less than 3 times the greatest. So once again, we have 3 consecutive integers. X plus 1, and x plus 2 are our 3 consecutive integers. 50 more than the least integer. The least is x. 50 more than that means I'm going to add 50 to it. 50 more than the least integer is 40 less than, which means I'm going to take 40 away from something. 40 less than, take 40 away from 3 times the greatest. Well, 3 times the greatest is x plus 2. There's my equation. I'm going to distribute that 3, and I'm going to get 3x plus 6, and bring down your negative 40, and you have x plus 50 on the other side. Oh look, I have variables on both sides of my equation, so I either have to get rid of these, or this x right here, or these x's right here. I'm going to choose to get rid of this. So the way that I get it, this is one positive x, the way I get rid of it is to combine it with a negative x. If I do it on this side, I better do it on this side. These x's cancel out. I'm left with 50 equals 3 positive x's and 1 negative x, means I'm going to have 2 positive x's left over. And oopsie, I forgot to combine terms here. This is negative 34. I need to isolate my variables, so first I'm going to find the term that contains my variable, which is right here. I want that alone, so I'm going to get rid of my negative 34 by adding the inverse, and I have to add 34 on both sides to maintain my balance. These 34s cancel out. I have 2x left on this side, and on the other side 50 plus 34 is 84. 2 times x, I'm going to divide by 2 to get my variable all alone. So x is equal to 42. X is my least variable, 42. So this is 42. This is 43. And this is 44. And according to this, the least plus 50, well, that would be the least, which is 42. 42 plus 50 would be 92. 50 more than the least is 40 less than 3 times the greatest. Well, what's the greatest integer? It's 44. So 40 less than 44 times 3 is 92 equals 132. That's 3 times the greatest. 3 times 44 is 132 minus 40. Well, 132 minus 40 is 92. 92 does equal 92, so I just verified that these are my 3 integers, my 3 consecutive integers. Solve 2 times the quantity, x plus 3 equals 12 minus x. I'm going to distribute 2x plus 6 equals 12 minus x. Can I combine like terms? These are not like terms. These are not like terms. I can't combine them when they're on opposite sides of the equation, so no combining. We did distributive, don't need to combine. Do we need to get all of our variables on one side? Yes, we do. I see variables here and here. I choose to get rid of this negative x by adding x so that those x's cancel out. I'm going to add x over here to maintain my balance. These x's cancel out. I have 12 over here, but no more variables on the right side. 2 x's plus 1 more x is 3 x's plus 6. I need to isolate my variable. Well, here's the term that contains my variable. If I want that alone, what I have to get rid of is this. The opposite of positive 6 is negative 6. Do it to both sides to maintain your balance. The 6's cancel out. I have 3x equals 12 minus 6 is 6. Get x alone. I'm going to do the inverse, which is divide by 3 on both sides. Cancel this out. X equals 2. Let's see if that works. If this is 2, this is 2 plus 3 is 5. 5 times 2 is 10. And 12 minus 2 is also 10. So we just verified that 2 is the value of x. Okay, solve. Let's do it over here so we don't waste so much paper. 5 times the quantity 5 minus x equals 4 times the quantity x minus 5. I'm going to distribute first, and I'm going to get 25. Positive times a negative is negative 5x. Got rid of my parentheses. 4x. 4 times negative 5 is negative 20. Can I combine like terms? Not like terms, not like terms. Can't combine them when they're on opposite sides of the equation, so can't combine, but I do need to get all my variables on one side. I have variables here and variables here. I choose to get rid of these 5 negative x's by adding 5 x's to both sides to maintain my balance. When I do that, I have, this is a positive 25. I'm going to bring that down, and my 5 x's cancel out. 4 positive x's and 5 positive x's is 9 positive x's minus 20. Okay, I'm ready to isolate my variable. My variable is right here. They're all on the right hand side. If I want this term alone, I have to get rid of negative 20 by adding its inverse to both sides to maintain my balance. These cancel out. I have 9x on the right side. On the left side, if I add 25 positives and 20 positives, I get 45 positives. Inverse of 9 times x, I'm going to divide by 9 because I want to be able to do that. There's my 1 whole. 1 times x is x. Since I divided the right side by 9, I had better divide the left side by 9. And 45 divided by 9 is 5. I'm going to pause and start a new video for the next one.